Ladies and gentlemen, good evening. I'm Ian Blatchford, Director of the Science Museum, and as always happens on occasions like this, we can send people into orbit, but we can't get a microphone to work. So that's inevitably something like that happens on an evening like this. Also, a very warm welcome to their Royal Highnesses as well this evening. Space exploration is on my mind every single day of the week because of the 3 million visitors who come to the museum, and the majority of those are children with their families or with their schools, they all seem to head for the space collections, even though our collections are sadly lacking, I must confess, in Russian technology. And space is exceptionally vivid in my mind this week because of the many laments in the international press for the last space shuttle mission, but also excitement about the unveiling tomorrow morning of the Yuri Gagarin statue in the Mall. Tonight's lecture is one initiative from the UK-Russia Year of Space, launched back in February by the UK Space Agency and Roscosmos. 2011 is dedicated to announcing new research partnerships in space science, as well as cultural events, including the British Council's Gagarin Week, to celebrate the 50th anniversary of Yuri Gagarin's heroic spaceflight. This lecture is also a joint initiative between the Science Museum and the Science and Innovation section of the British Embassy in Moscow. The aim of the Innovation section is to create world-class science partnerships between the UK and Russia in areas such as space science and nuclear and particle physics. 2011 is also the 20th anniversary of Sergei Krikalev's flight with Helen Sharman to the Mir space station, and I'm particularly delighted that Helen is here this evening as well. We are incredibly honoured to have tonight's speaker here this evening. He is the world record holder for the longest time spent in space, and I love this number, 803 days, 9 hours and 39 minutes. I know that I could have only survived 39 seconds, so it's an extraordinary record. And therefore he is staggeringly well qualified to talk about what's been happening in space in the last 50 years. And therefore, without any further ado, may I introduce tonight's speaker. Thank you.
This mic is working already. I would like to have more conversation rather than just lecture about spaceflight, so I will flip through some slides and maybe we can think a little bit about what happened before and maybe think about what is going to happen in the future. But then I would like to have your questions, so please think about questions during this talk, and I will try not to make you too tired from this. So this year we are celebrating 50th anniversary of Gagarin's flight. It happened, seems like not long time ago, but already 50 years passed, and a lot of events happened at this period of time. Let's see if it's going to flip pages. It doesn't. Can you switch to next slide? Thank you. So, Gagarin, let's see if it's still not working. Gagarin flew 50 years ago, and the training center actually was formed just a year before Gagarin flew. So now, training center named after Gagarin. Next slide, please. So this flight was done on Vostok spaceship, and this is relatively small spacecraft. It weighed about a little more than 4 tons, and dimension of the capsule was 2.5 meters. It was built to fly one person, and Gagarin flew only one orbit, a little more than 100 minutes, 108 minutes, and it was also built from 2 parts. Descent capsule and another compartment that hold all automated systems, supply and engines. And it was only, as I said, small capsule. Gagarin flew one orbit, and it was built actually for staying on orbit for 10 days. So Valery Bykovsky on Vostok 5 capsule flew for 5 days already. Next slide, please. Valentina Tereshkova was the first woman in space, and she flew on Vostok 6 capsule. Next slide. After Vostok, next spacecraft was Vashod, and this capsule was built already for 2 and more people, and using this spacecraft, Alexei Leonov in 1965 made first spacewalk. So he was in his spacesuit inside the capsule, and capsule built in such a way that they can go to airlock and then go outside and return back. Next slide. After Vashod, next spacecraft was Soyuz, and Soyuz was built from 3 compartments. 2 of them were flying in space, were habitable. One is habitation module, and another was descent capsule. And actually, this habitation module was kind of beginning of space stations. We need to study if human can stay long enough in space, and longest flight on Soyuz in space was 18 days. So we realized that space is harsh environment, and we need to take special measure to keep people in space longer. But then we had 7 Salyut space stations, and all of them were a little different. First Salyut started as a station when just with 1 docking port, and crew were able to dock, stay in the station for a while, and then had to leave because there was no possibility to resupply. And it was launched in beginning of 70s, and last Salyut 7 station was launched in 82 and flew for 4 years. It was already stationed with 2 docking ports. It had systems to resupply not only cargo through the hatches, but also liquids. So fuel can be pumped from cargo spacecraft to Salyut station. So all of them were different, and each model allow us to study space and stay in space a little longer. So after Salyut stations, we had a Mir station. That was station of new generation, built from several modules, and it served for 15 years in space. Next slide. We had up to this point, June 2011, we had very many cosmonauts in space. More than 500 persons flew in space from 35 different countries. And in Russia, we have more than 100 people flown in space. Most of them were long duration missions. That's why we had less people in space. But also we start our international cooperation. And this slide shows how many missions different cosmonauts made in Russian space program. Next slide, please. So talking about Mir station, as I said, first module was launched in 1986, and it was only this small part, core module of the station, actually very similar structure with Salyut station, but it was built in such a way that through docking compartment there was possibility to dock several modules to the same basically node on the station. Second module was Quant 1 module, and when I flew my first flight, station was had only two modules assembled. And a few years later, when I flew my second mission, we had 2 more modules docked to the station. So the station was growing with time, and you see configuration of the station when shuttles start to fly to Mir. So we start to have not only visiting missions, but also two big space programs, Russian and American space program, start to get together on this station. Next slide, please. So, talking about my experience, we are celebrating 50th anniversary of manned flight, but my first flight was in 1988, more than 20 years ago. So, my experience with space program going together for last 20 years. So that was training for first flight. It was also international mission. Jean-Luc Chrétien from France, Alexander Volkov and I was training for this flight, and our flight start from joint mission, as actually we had some kind of overlap with a previous mission that set record time being in space. Expedition 3 on Mir stayed on orbit for a year. So we came and stayed together for 3 weeks, and then Jean-Luc Chrétien depart with Expedition 3, and we stayed for a few more months doing our job on orbit. Next slide. So that's my second flight on Mir station. As I said, station was a little bigger at that time, having 4 modules instead of 2 for Expedition 4. And we started our flight together as Soviet-British flight. You see some pictures taken during our training, preparation on Baikonur, and that was just last press conference before the flight a while ago. And during this mission, initially this flight was scheduled for 5-month Expedition 9, and this flight was very interesting because Anatoly Artsebarsky and I did several spacewalk, and we actually built very interesting structure, actually big truss that was built using memory alloy material. So it was interesting technology, interesting technique how to build it from relatively small pieces. And we did 6 EVAs to build it. Actually 5 EVAs, because first one was done to repair one of the antenna broken on previous mission. So, but in the middle of this flight, I was asked to stay another mission on orbit. Helen already departed at this time, and my second portion of this flight was with Alexander Volkov. I flew with on my first mission, and we did another EVA during second part of the flight. So at the end of the mission, I had 7 EVAs in one flight, and I believe it was at that time it was also a record time of being outside of the station, working in open space. Next slide. So right after this flight, I was assigned to first joint U.S.-Russian flight on shuttle. Vladimir Titov and I came to Houston for the training at the end of 1992, and we were training together with a crew of STS-60 mission. It was a very interesting flight. We did some medical experiments. We worked with a robotic arm and made very interesting experiment with a facility called Wake Shield that allowed to create very pure vacuum actually behind the special shield, allowing to grow a film of semiconductors there. And also we had fun, and maybe you know that Charlie Bolden became head of NASA. I saw him a few days ago visiting final shuttle flight. Next slide, please. So then after this flight I was assigned as a member of Expedition 1 for International Space Station. All pieces, all equipment was still under development, and all pieces were staying on the ground, building on the ground, assembled on the ground, and we start training when even simulators was not ready at this point yet. So creating of the station and our training was going together, and prior to flight as member of Expedition 1 crew, I flew another flight assigned kind of late for first assembly flight. Because initially a program of STS-88 mission was only to dock node, first element, US built element, with first Russian built element, functional cargo block that was launched from Baikonur. So the mission was to rendezvous with FGB and dock the node with FGB and then depart and leave. Later on the flow, decisions were made to open hatches and do some maintenance inside the station. So it was supposed to be first not only assembled but first visiting mission to ISS, and I was assigned to this flight as crew member who already have experience of long duration flight, work on space station, and also have experience of shuttle mission. So that was our crew. On final stage of preparation, actually we were doing emergency training on Cape Canaveral, and that's already picture done in space when we were preparing of doing EVA and do some assembly on the station outside. And as I said, later on, Bob Cabana, who was commander of this flight, and I opened the hatches and together flew into the station for the first time. It was end of 98. Sorry. Next slide. So that's the way how station was changed. That's a picture of FGB, as I said, functional cargo block launched from Baikonur in beginning of December 1998, and then STS-88. Actually, it was picture taken from this flight. Dock American module, this module node, to make it first space station. Later this year, 2 years later, sorry, Russian, what we call service module, or basically similar to Mir core module, was docked with the station, and station was able to receive first crew, first expedition. So at the end of 2000, Expedition 1 flew to the station, and we were staying on the station for the first time, long stay, making station basically alive. Next slide. So this is information about space station right now. American part of the station, US segment, what we call, is already assembled. That's why shuttle can retire, because assembly of US segment was completely dependent on shuttle, because all these modules were delivered and docked with the station using shuttle and station robotic arm. On Russian side, we had this on left side of the station. We have some module already assembled. All of them were docking autonomously, because they have capability fly independently and dock with the station with no maneuvering of station for the docking. And Russian segment is not assembled yet. You will see future configuration of the station little further. Next slide. International Space Station is a big area of international cooperation. Now we have already 28 missions flying to space. 2 years ago we switched from 3 crew members to 6 crew members on board. All delivery of long duration crew is now done by Russian spacecraft Soyuz, and Soyuz can feed only 3 crew members, as I said. That's why at this point we have 2 Soyuzes already docked with the station, serving not only as delivery and return, but also like lifeboat capsule. Next slide. So first mission start, as I said, in October 2000. That's some pictures from the training. Bill Shepard, Yuri Gidzenko, and I was member of the first crew. Usually we have mixture of experienced and not experienced crew member to share experience and be able to transfer experience from one crew member to another. But for Expedition 1, a decision was made to have all flown cosmonauts and astronauts to be sure that if we have any difficulties during our missions, we will have more chance to overcome all these difficulties. So training was done in Soyuz spacecraft inside mock-up of the station. Here the picture from winter survival in a forest, and also big picture of flying in weightlessness in zero-G airplane that was doing parabolic flight, and for a while we can experience weightlessness and do some exercise in this huge airplane, getting acquired to weightlessness. Next slide. So my sixth flight was in 2005. If you remember, 2003 we had a tragedy of crashing shuttle when 7 people were killed, and all shuttle flight was stopped for a while. So we used to start from Expedition 1, having 3 crew members on board. Usually it was 1 Russian, 2 Americans, or 2 Americans, 1 Russian. We were kind of even on this flight, but after this tragedy in 2003, we had to reduce number of the crew to 2 person because delivery of cargo was scheduled to have space shuttle available. So to be able to maintain crew for a long duration time, we had to limit number of the crew to 2 person. So my 6th flight I flew with John Phillips, and in the beginning of the flight as a visiting crew member was Roberto Vittoria, who came with us and departed with previous crew. So for majority of time we stayed with John Phillips together. And as I said, this is a picture again inside the Soyuz capsule, and one of the training in the pool, in Hydro Lab, what we call basically neutral buoyancy lab. Next slide. So when talking about space infrastructure, we should not forget about ground infrastructure, because all facility was prepared and launched on Russian side from Baikonur, on American side from Kennedy Space Center, and a lot of people are working there, making assembly in space available, making us able to have pieces in space and dock things in space. Now we start to work on another cosmodrome, another launch site far east of Russia, and I probably will answer on some of the question you have. It's not going to replace Baikonur, it's going to be extra ability to launch spacecraft. So when we will build this infrastructure, we will have ability to launch spacecrafts from Baikonur and Vostochny. Next slide. A little more word about Gagarin Cosmonaut Space Training Center. This is a picture from air. As I said, big pool located here, Soyuz and station equipment mock-up installed inside. We also have a big building for huge centrifuge that allow us to simulate G-load and have training of cosmonaut in the next slide. Here you can see some of the equipment we use to get cosmonauts ready to fly. As I said, Soyuz mock-up space station, mock-up. We train people in weightlessness using Ilyushin 76 aircraft that fly parabolic flights and able to have a little less than 30 seconds of weightlessness in it. We have huge centrifuge, 18 meters in diameter, that allow us to create G-load the same as we experience during flight in nominal and off-nominal modes. We have hydrolab where we can exercise, work outside of the station, having neutral buoyancy, actually creating us the same difficulties as we have during EVA in weightlessness. So that's another tool we use. We also train people to survive in case of emergency landing somewhere in the sea or in a forest, in mountains. So that's another part of the training. Also, we use specially built planetarium that actually is different than many planetarium we have here on the ground, because usually we project stars only for hemisphere. And being on orbit, you are a little high above the ground, and that's why you can see more than 180 degrees. So this planetarium allow you to simulate what you can see in space and maybe help crew to do manual attitude control of the vehicle in case of malfunction of computer or other necessity. Next slide. So also, as part of cooperation, we have already two automated transfer vehicle, ATV, built in by European Space Agency, and we have mock-up of ATV in here, and also we have mock-up of control post on the station that can be used to manually dock progress vehicle. So if something happened with automated system, we can use these hand controls to fly unmanned vehicle in the same way as if we were in this vehicle. For ATV, control was a little simpler, so we were not able to manually fly it, but also we were able to provide safety. So in case something happened, we can stop or remove this vehicle from dangerous vicinity from the station. Next slide. And as I said, doing our international cooperation, we do a lot of training together and fly together with European cosmonauts. Some of them, Paolo Nespoli just recently landed on the previous mission, and they were back in Russia for post-flight debrief. Andrei Kaupers is on training for his next flight, and as you can see, some of the crew members already flew on the station several times, twice actually. Next slide. Also, doing our international cooperation, we had new European astronaut who recently came through selection across Europe, and they are doing their astronaut basic training in Houston in European Space Agency, and for a couple of months they had practice in Russia, getting familiar with Russian equipment and do some Earth observation training in Russia. Next slide. Talking about professional cosmonauts, we should remember about non-professional cosmonauts who start to fly to space relatively recently. Denis Tito was first American actually who flew on Russian spacecraft as a guest, as a visiting person. So several people were on training. Some of them already complete their mission, and actually one of them, Charlie Simoni, flew on his flight twice. So that's new thing we start to do, start from International Space Station, because before, both in US and Russia, we have most of cosmonauts professionals. Some of them were not professional in flying vehicle, but they were professional in science or other areas. So non-professional cosmonauts and astronauts are new things for new program. Next slide. So I was talking about future development of Russian segment of the station. As I said, FGB and Node was the first two elements, and US segment already completed on US side, and on Russian side we are going to launch another multi-purpose laboratory, new module that is going to have also European-built robotic arm on it. And next step would be to add two new modules that will allow to have more electricity, more power supply for Russian segment. Next slide. Also, as part of the future plans, we have so-called AK module that is able to fly autonomous flight. Speaking with scientists, they complain that sometimes microgravity conditions on the station, on manned space station, is not pure enough, not adequate to requirement they have for some scientific experiments. So having some kind of autonomous spacecraft that can fly and conduct experiments in quiet and clean environment, and then it can come to the station, dock with the station as a cargo vehicle are doing right now in automated mode or maybe even manually controlled mode. Then crew can service some of the equipment, replace different samples, retrieve some samples from this vehicle, and then let it fly again in autonomous mode, staying again in pure weightlessness, not be disturbed by crew activity. Next slide. Talking about experiments, we have big variety of experiments, and there was number saying how many different experiments we did in space, but they are in different mode. Many of them done in international cooperation, like this plasma crystal experiment was one of the first. Actually, we started it plasma physics experiment, and we started on Expedition 1, and it was successfully conducted through several missions and modified, and now new generation of the same equipment is flying in space. Also, we have small greenhouse in space. We study environment inside the station and study particles and influence of solar wind and space particles inside the station, having Matryoshka experiment. Next slide. And as I said, this is a result of one of the experiments we did in our small greenhouse. There is another experiment going in US, in Arizona. They have big greenhouse that can be model of future environment for lunar or Martian base. Next slide. And then talking about station, we should realize that one of the most difficult and challenging part is flying up and down, going through atmosphere. We used to have Soyuz spacecraft on the US side. It was Apollo spacecraft and shuttle, and now many other players start to build different spacecraft. HTV is automated spacecraft for cargo built in Japan. There is a Dragon capsule that built by SpaceX company. NASA is working on new spacecraft, Orion, or maybe it's going to be called different way, but it's going to be probably a multi-purpose crew vehicle. In Europe, as I said, already built automated transfer vehicle that already twice flown to space. So I think in nearest future we are going to see big variety. Actually, Dragon capsule was supposed to fly end of this year, demonstration flight and have approach to the station. But now we are talking about maybe a combined second and third flight of Dragon capsule, and if rendezvous is going to be smooth, we will see if this capsule can dock with the station. In this case, we will have another opportunity to deliver cargo to the station. Next slide. So, talking about ability of people flying to space, also we have more and more commercial applications for space. So you probably heard about Virgin Galactic's that built spacecraft that can fly much bigger parabola than we can do on Ilyushin 76. It can fly up to 100 kilometers in space and have weightlessness for about 10 minutes, maybe 7-10 minutes. It's going to. I know that many people already waiting in a line actually to be able to fly these parabolic flights. One of the reasons that it's much cheaper than flight on Soyuz on one hand. On the other hand, if you see how much 1 minute of weightlessness costs, it's about 7 times more expensive than fly on Soyuz because this weightlessness is relatively short. Next slide. So maybe not only short suborbital flights can be commercial. There are some plans to have a small station, like small hotel in space. We will see. There are several projects and several designs. We will see which one will work in future. Next slide. And talking about future flight, as I said, there are government and agencies. Government agencies will still play a major role in future study and future developments. And there is some job for professional cosmonauts, for professional missions, and maybe some commercial companies will do tourist missions. We will see. Maybe in the future we will see more mixture of these tasks, but let's see what happens in future. Next slide. And that's what I wanted to show, because we were making a picture of Earth sometime as a part of our assignment, but sometime because it just looked nice. And many of pictures were done and now showing on different exhibition around the world from different missions. And this picture, one of the nice sunset near equator actually, where you can see huge thunderstorms, and on low sun it looked very nice. Next slide, please. This picture actually was taken, I was trying to see my hometown, St. Petersburg, and it's taken from more than 1,500 kilometers from St. Petersburg. We're never coming close enough because of the inclination. But this is a Finland Gulf, and this part is Finland. Ladoga Lake, and St. Petersburg is somewhere here, but that's kind of unusual view in Sunglint, and you can see all small lakes in this area. So sometimes initially I thought that it's too dark and too hazy to have a good picture, but then sun reflection actually shows this outline very unusual way. Next slide. So it's another nice picture of Crimea Peninsula, place we used to be in underwater expedition when I was student. So you, of course, see different places, but most of the time, some places you were before attract you more than others. Next slide. And that's probably a very well-known picture. This is impact crater in Arizona, and we see a lot of craters on the moon. Usually, Earth's atmosphere protect us from hitting big asteroid on the soil. But that's one of the example when this space material went through atmosphere and actually impact on the ground. Next. And that's how volcano look in actually rainforest. So that's very interesting picture also. Next slide. That's what I wanted to say, that we, in 50 years, we went through many different adventures, but as Arthur Clarke said, we're just in the beginning of our way. So thank you for your attention.
Thank you very much. That was a fascinating talk. Your Royal Highnesses, ladies and gentlemen, we have some time for questions. Just while we're thinking of the questions, if I may ask you one question. I met you for the first time yesterday, and I noticed you are a little bit taller than I am, and I was wondering how you fitted into your Soyuz spacecraft.
Folded several times. Actually, we have height limitation for Soyuz capsule, but major limitation is actually what we call seating height, because when we are staying in the capsule, the size of your spine actually what's important. So for a person who have longer leg, they can afford to be taller than others to fit in the capsule. And I would like Helen to join me for answering questions, because we flew together, we are crew, so we have to take this challenge together also.
So, in time-honoured tradition, could I ask if you have a question to ask, could you please raise your hand and the microphone will find you. So do we have any questions? Yes, we have one in the middle, about 6 rows down from the top.
Who is working with mic?
Keep your hand raised, yes.
I've heard that Russians carry pistols and shotguns aboard their spacecraft. Did the Americans object to that?
No. They also train to use it when they fly on Soyuz spacecraft. It's actually, we have special kit, survival kit, we have in Soyuz capsule. And in case of emergency landing, we may need different things, start from matches, fishing hooks, or pistol, if we need it. So everyone go on training and remember that.
I remember shooting the first time I'd ever shot something in the sea, just so yeah, learning how to survive afterwards.
But this is a specially built gun with 3 barrels, 2 of them smooth barrel and 1 as a rifle for bullet, and 2 upper barrels you can use just to hunt or send a signal to rescue vehicles.
We had a question from the gentleman in the red shirt just here.
Hello. Thank you very much for the talk. I'm very interested. Do you think we would be a lot further on with the International Space Station and the technology had the Americans pursued the X-planes rather than Apollo?
X-planes? What that?
The high-speed planes that were making the boundaries of the atmosphere, and all the emphasis in that generation seemed to pull from there onto the Apollo project.
Well, if you are talking about suborbital flight, what was done, that's only part of the technology, and actually the problem for all suborbital flights that when it reach its altitude, it's actually go basically on parabolic flight, and at the top of this trajectory it has no velocity, 0 velocity, and then it goes down, and then another question how to dissipate this energy. But shuttle, Buran, and conventional rockets we use for orbital space flight, at the top of the trajectory you have orbital speed that is about 8 kilometers per second. That's significant difference in energy you have to have. So I think space plane was useful as a first part of the development, but then basically shuttle was built as extension of this space plane, and we had the similar spacecraft Buran. Unfortunately, this program was very short, and the Buran flew only once in unmanned mode. Well, there are different ways how we can build spacecrafts, and I know that plans for US side that after shuttle grounded, they are going to build a capsule similar to Soyuz or Apollo capsule. So it's balance.
A question from the gentleman sitting just up there, the red tie.
I was wondering whether you were taking precautions against hits from space debris. As we all know, there is a great deal of rubbish left in the atmosphere, and I imagine it is a considerable threat. And I was wondering whether you were taking measures to cope with it.
Well, I agree with you. It's a threat, but well, how considerable? It should be considered, and of course, we're tracking all possible debris we know. And talking about precautions, what we do for the station, knowing trajectory, we can predict trajectory in future. And if one piece of debris is coming closer than 10 kilometers to the station, actually somewhere in this vicinity, then we will do small maneuver for the station that actually move our intersection point beyond this bubble, beyond 10 kilometers. So that's what we do. In case actually it happened just recently when we got information about it kind of late. I don't know why it happened. Maybe piece was very small, maybe it was new piece of debris coming in our view. But when we realized that it doesn't make much sense to do maneuver, because maneuver usually is relatively small, and it makes sense when you do it early enough. And in this case, even small deviation bring you far enough from this debris. But on late stage, what we did as precaution measure, we asked crew go to Soyuz spacecraft as the most protected part of the station. And actually, what we have on our procedures for loss of pressure in the station on different reasons. Is it collision with debris, malfunctioning of one of the valves, or some other reason? First thing what crew does is going to Soyuz capsule and check integrity of capsule. And if it's okay, then crew can try to save as much equipment as possible, but they still have, as I said, lifeboat Soyuz that allow safe crew even if we have small collision with the station and loss of the pressure in the station.
If I can add to that, I remember seeing on my bedroom window on Mir a small dark spot, and the people who were already there proudly told me that yes, that was where a small meteor had hit my window just a few days before. So of course the outside of the station is peppered with these very tiny hits.
And actually, I don't know if we can consider it as debris, because we have natural particles moving across the space with different speed, and actually smaller the particles, more of them in space, and more probability you have to collide with the station. So I agree with Helen. We have on the window it's most visible. So you have very small scratches on the window, and sometimes you cannot even see it. You have to have special lighting condition when sun is going on shallow angle across the window, and in this case you can see even small scratches. Some of them really small, some of them little deeper, and the biggest I remember was probably what you mentioned was, I don't know, maybe a couple millimeters in diameter.
Is there a question?
My name is Mark Brannigan, and I go to Hill House International School, and I wonder if we could be able to live on new planets in the future.
Of course, that's why we do all this research and development in space. And actually, being in international school, you have more chances to be part of international crew in future.
The question is, would you like to go and live on another planet? You would, good.
Keep your hands nice and high so you can hear them. Gentleman in the middle here, and then we'll have this gentleman first. Was there a question at the front as well? Yes. Paul, perhaps you could ask yours first. Thank you.
Sergei, thanks very much for a fascinating talk. You spoke a lot about some of the physical training that you went through as a cosmonaut, and I wonder whether you and Helen could tell us a bit about whether you went through any psychological training and whether you now give psychological training to cosmonauts and astronauts who will be in space for longer.
For me, it was as much psychological selection as psychological training. We were carefully selected on some British psychologicals and also some Russian psychological tests. And then once we were training, there was obviously people looking at how we are interacting with the different crews as well. And I think most people can get on with most other people in the astronaut corps. They're chosen because we're, I think, very similar, often fairly, let's say, stable personalities. We don't tend to get highly excited, and yet we don't tend to get highly depressed or deeply depressed either. And people are chosen because they're nowadays very good team workers, a very different kind of psychological testing to that which would have been required for the early Apollo crews, who had to be highly reactive people. And I expect, I don't know if Gagarin is more of our ilk or of the older ilk.
Well, I think I agree with you. Training is training, but I think most of things done when we go through selection process, and we basically try to select normal people, and then we have everything normal in space. But also I think getting ready for long duration flight, you go together, the crew, through many travels, you stay in confined environment, you go on survival training, so you see that if any problems we may have, we can see it on early stages of training. So, but I don't remember having problems with that through many years. Some crews get better together with each other, some not as good, but we never had serious trouble that force us to change the program.
No fights in orbit.
Thank you for your patience, sir. Your question.
I'm thinking about the prospects for a future mission to Mars. And I'm wondering, are there physical limits on how long a human can survive in space for a journey of that length? And also, is there a chance for greater international cooperation to make such a mission possible?
Well, in terms of how long can somebody survive, I think Sergei's the ultimate answer here. So, over a year,
800 days.
Yeah, in total.
It's already more than needed to fly to Mars and back, I guess.
And also afterwards, there's a lot of checking of the astronauts when they come back, especially the young long-duration flyers, and how they're coping with coming back to Earth. Because I think, is it not true that coming back to Earth is actually harder than feeling weightless?
Yeah, that's different people who feel different way, and depend also on length of the mission. Because if someone flying short mission, probably what you did, it's not as difficult to be on the ground after a short stay in space, because your muscles still strong enough, you don't have any significant change in your bones. And for long duration flight, we know about all these changes, and that's why, not knowing, as you said, where is the limit, not knowing the limit, we go step by step, basically trying to find the limit. As I said, Expedition 3 on Mir stayed in one flight on orbit for a year. Musa Manarov and Vladimir Titov. They stayed for a year and they returned back in good enough shape. And we also study not only what to do in space to keep people in good shape, but also how to make them able to come to system again. So we need to go through special rehabilitation program to return back their strength and health. So we don't know where the limit is. We're studying, we know that limit is far enough, and that's why, actually maybe you heard about Mars 500 mission. that basically psychological experiment. It's not something where we imitate tasks, assignment or science for space. The biggest science what was done in this mission is actually to see if people can stay in confined environment for long enough time. And as I know, experiment is going well at this point.
One of the biggest things about being in space for me is that you only have a very small number of people with you. When I was there were 3 of us on Soyuz and then 5 of us on Mir. When I left with 2 of them, then there was just yourself and Tolia. So if you imagine just being with one other person for what became 5 months, it's a long time.
And actually also with duration of the flight, trying to find the limit, we got information that 1 year is not a limit. But then we realized that the efficiency of the flight is going down because people get tired. So we limit our missions. Normal mission now is about half a year. And it's very close to the limit. Soyuz have staying on orbit. So it's a good combination when you have already enough experience. You are on a kind of learning curve in the beginning of the flight. But then you are productive. Then at the end of the flight, your efficiency goes a little lower. So I think it's 6 months is a good balance for stay on orbit for orbital missions.
There's a gentleman in the middle over here. If you could raise your hand nice and high, wait for the microphone. You've been waiting a long time. While the microphone finds you, I was wondering what your thoughts were on a proposed or a speculated mission to an asteroid, a human mission to an asteroid.
My own opinion, that's possible missions, and it might be even earlier than we go to Mars, because landing on asteroid is going to be easier, and more important, taking off asteroid can be easier, and we can have a significant scientific result from this, because most of asteroids built from the same materials as other planets, and we study basically 2 celestial bodies, Earth and Moon. So having one more data point, we will go significantly further, understanding how our solar system built, how planets were formed. So a lot of information that we can get from Mars mission regarding material and planetology, we can get from asteroid mission.
Yes, sir, if you could ask me a question, please.
I was going to ask, what was the most interesting experiment you did in space, and what were your findings?
Well, one of most interesting experiment, I think, was basically assembly of International Space Station. Because people don't think that it's experiment, but really it's a huge technical experiment. We did several technical experiments, seeing how we can unfold solar arrays, how future antennas can go, and actually on my first early flights, we had international experiment studying opening complex infrastructure in space for future development, but really creating space station when many of pieces were built separately, and usually here on the ground in Russian and US systems, we do mock-ups, we do fit check for different parts. Even a small piece of experimental equipment that is going to fly to space is going to special test bed on Earth and do fit check to be sure that everything is fit. But creating International Space Station, some of the pieces never saw each other unless it was docked in space. So talking about challenges, this experiment is great, and we had some difficulties. Actually, sometimes, not very often, but sometimes connectors didn't fit when one module was connected to another, and we had some interference with electricity, but finally all these problems were solved. Talking about pure science, what you probably are asking for, experiment I liked a lot was plasma crystal experiment, I said, and It has very many future applications. Actually, when we were going through training, and it was a joint Russia-German experiment, and as I said, it was first beyond life science. It was first real physics experiment on the station, and the result we got from this flight require for scientists to stay in their offices for several months thinking about result they have, because we got some phenomena people didn't expect, and actually initially we thought it's malfunctioning, but really now they have little better understanding, and describing us finding from data we returned back on the ground. Scientists told us that this finding can be used in the future equipment for material science, for very precise control of complex material when you put several very small samples on the plate and then remove all of them and bring new set of material and very precisely put them in very pure environment. It may be efficient for future electrical power cells that can give you electricity for a long period of time, and also even for fundamental science, they get new data and they actually re-evaluating how our solar system was built, because the way how particles go together, and actually it was again some data we got during a failure of some part of this equipment. So instead of getting particles in kind of evenly spread mode, it started to came with clusters. So information how this cluster was formed actually give them new data on basically understanding how our universe is built. So it goes on very long range of results, and the experiment itself was very interesting. Equipment was unusual, so talking about me, that's one of the most interesting experiment. If you ask about opposite side, most unpleasant, although I know that we need to do a lot of life science to understand how human change in weightlessness, we need to understand little more for future long duration missions, but something like blood draw from your partner was not my favorite.
I had to take blood samples and nobody liked me for that. But most of the experiments are in boxes, so you can't actually see what's happening. And one of them that I could actually see was a miniature tree I had to take up, which was really a psychological experiment. The idea was that I would leave it behind and then people would look at this piece of green, and it would remind them of life back on Earth and help them to feel a little bit more rested and less stressed. And I remember, I don't know if you remember, we had problems when we first arrived. When we eventually got out all of our stuff from Soyuz, I presented this miniature tree in its little Perspex box to Musa. Mm-hmm. And he looked at it and he said, "Oh, where am I going to put this? I know, we'll just get rid of it out of there, out of the way. Just one more thing we could do without." So that was one experiment that didn't really work very well, I think.
Further deforestation.
That's why it's an experiment.
We have about 5 minutes left for questions, so raise your hand nice and high. We're not having many from over here. Any questions over here? Right at the back row.
Hello there. You've mentioned obviously the limits that psychological problems can pose from long-term spaceflight, and obviously there are things in near-Earth orbit that can be more easily solved, such as cargo resupply and waste disposal. But in terms of interplanetary spaceflight and long duration, what do you believe to be the ultimate limiting factor of the human body, which we wouldn't be able to overcome and which we'd have to hand over, for example, to robotics?
Well, we have a lot of natural limits for human body. As I said, carrying very heavy load, we are not able to do this even here on the ground. So we limit with human strength and some other limits. So what limits we cannot overcome? Well, unless some obvious limits we already know, I don't know. that's why we do all these experiments. Maybe you can.
Well, I agree. We say the world is your oyster, so we don't limit ourselves. There's nothing that we see is not possible in space. And like I said before, it's actually easier. The biggest problem is when you want to come back home.
There was a question from a young lady around there. Yes, very close to the mic. Thank you.
Was it possible to drink water in space without any risks?
Yes, we do this for years actually. Although, to be sure that water is not going to be spilled in weightlessness, we have special, how you say?
A mouthpiece.
Mouthpiece, yeah. So you just basically pump water into a plastic container or sometimes even direct to your mouth. And when you have enough skills, then you don't need even to use this mouthpiece. You can just have a water stream and then just swallow the water flying from space. But then actually pieces of droplets of water came in a bubbles, and this bubble is actually staying together due to surface tension, right? Surface tension, and it's very unusual sight. When it starts to oscillate, it's kind of very weak forces that hold everything together. So if you little blow or touch the water, it starts to oscillate. It's very nice view.
I sometimes wonder what it would be like to have a bath in space, because I mean, taking a shower takes a long time. Is it 8 hours to set the shower and use it? And
yeah, we had a shower on Mir station, and it was kind of complicated procedure to get everything ready. We had to assemble some pipes together, heat water, clean water, and actually what we do, because we don't have weightlessness, and in weightlessness we cannot use shower the way we do here on the ground when water just drops down. We had to use airflow. So, and airflow works better on smaller particles. So it's not really big droplets, it's kind of very fine droplets, spray, yeah, and it you have to wash yourself and then wash the shower itself, cabin, to be sure that no residuals will left there. So we found that it's not very convenient, and what we do, it's easiest way we do this on Mir station. We did it on shuttle, and we still do it on ISS. Just use wet towels and just clean yourself using wet towels.
It's like having giant baby wipes, and that's how you wash your hair as well.
But actually, talking about water, I remember my feeling after first long duration flight when I returned back home, and in space you limited with air, with water. You have to be careful using all of this. And when on the first day after landing, when I went to bath, and they filled it with water, and I kind of sank in it, I was thinking that probably in half a year I used less water totally than it was in this bath.
Wouldn't it be fun if you could take that bath in a drop of water in space, if you could have this huge drop?
Maybe it's going to be interesting.
Somehow.
But again, here you float in the water, and in this case, water will float in air, and then you will float in the water. It's going to be interesting.
So many questions. Before I hand back to Ian Blatchford, we have time for one more question. So you need to hold your hand up very high. Yes. There's the lady. 1, 2, 3, 4. That's right. Just down here, please. Thank you.
My question is mostly for Helen. Obviously, you are there's 4 British people, born people, being into space, but you're the only one that hasn't had to change your citizenship. What do you think about Britain's lack of funding for manned space flight, and should we be doing more, or should we be saying, well, fair enough, let's let other people do it?
I think Britain's lack of funding up till now has been atrocious. We did fund human spaceflight up until the Challenger accident. We had 4 military people training with NASA, and then Challenger happened. NASA said to all their foreign nationals now, go home until we've fixed ourselves. And then when it was fixed, by then Britain had decided that we weren't going to fund human spaceflight anymore. And that has been the case even up until now, even though we have now a UK Space Agency, so maybe, and we have Tim Peake, who's been trained to train, has begun his training. We saw a photo of him with ESA now. So maybe the tide is turning. But yes, I think that if we're not careful, Britain's just going to get way left behind. This is something that's happening internationally, that humans have a natural desire to explore, and that Britain needs to be at that forefront. We've always been an exploring nation. Why stop now? And this is exploring science, it's exploring our area around us, and looking further and further. And that's, Arthur C. Clarke, you showed a picture of him with one quote. Well, there's another quote of his, as he wrote at the front of my book, actually, and he said that when an organism ceases to explore, it begins to die. So we need to bear that in mind very much. Britain doesn't want to die, we're up there. And now's the time to get back in quickly, I think. Thank you.
Ladies and gentlemen, I was thinking to myself as Helen and Sergei were talking and sounding so incredibly calm and brave about everything they've done. I was trying to imagine all the people I know, either work with or all my family, and trying to imagine being in an international space station with them. And I don't know about you, but I'm not sure it would be a very happy experience. I'm sure they would say the same about me, by the way. It's not just that I'm calm and reasonable. I think really that was simply fantastic, not only your talk, but also the question session. And I'm sure we could go on for many hours, but I'm sure you'll be swamped by people the moment we finish. But really, I think the only way to end the evening is to thank both Sergei and Helen for the most fabulous talk. And I think a very loud round of applause is needed.